Hi all, this is Mr. Yeager for chemistry. We are moving into our unit on solutions, which goes over quite a bit about mixtures, kind of gets more specifics on types of matter. We are expanding back out from our submicroscopic state, not saying that we are completely leaving it, but we are now looking at, obviously, what we would call this macro view of actually seeing the substances that are in front of you and describing how we can combine them, how we can put them together to create these different types of mixtures. So in order to do that, we need to first go over the types of matter. Again, this presentation was made by another wonderful chemistry teacher. So here we go. All right, so if you didn't realize, you're still in chemistry, and if you needed a reminder about the definition of chemistry, it's again the study of matter and the changes it undergoes. I think it's funny that that is still in this presentation, even though we've been doing it for all year long. But I guess in a way, it's a good one to remind us because again, we are now looking at the larger substances in front of us and looking at how they are interacting and how we're going to separate them and a number of other things. Okay, so we've been talking about matter all year long. Okay, it's just we really jump straight to the atom, which again is the smallest unit of matter that has all of the chemical and physical properties of the larger substances that it is made up of. Okay, and so a general definition of matter is anything that has mass and volume. And so again, that would be basically everything around us, except for a few things that we would interact with, which would be light. I'm going to say I kind of disagree with electricity because electricity is electrons, so okay, maybe that one's not the perfect one. But light and sound, I could understand that, or would be examples of things that aren't electricity or aren't matter that are interacting around us. You know, you get silly examples like, guess what? Emotion and feelings are not matter. Okay, well, that's kind of obvious. All right. So anyway, again, matter is anything that we have to obviously have as it is. It has mass and volume. I guess the tricky ones would obviously be things like air. Because we can't just say something that's tangible because we can't sit there and feel air. I mean, we are feeling it, but I'm getting probably too technical with it. All right, so there's two general categories of matter. There are pure substances, okay, is our first type. And as the name implies, this means it's completely made up of one type of substance, one type of matter. Okay, that the entire thing, as it says, is uniform. We're going to be using that word some. Uniform means it's the same throughout. Okay, and so examples of pure substances are things that we've been using all year long: elements and compounds. So when I have elements like gold, silver, if I just have gold, that is a pure substance because that gold bar is entirely made up of gold atoms. We do include compounds with this, because compounds are a combination of atoms that have chemically reacted and are something brand new. And so a compound itself is completely unique. And so if I have something like water, it is entirely made out of H2O compounds. It's not a mixture of elements. We're going to learn mixtures don't chemically react. Compounds are atoms that have combined and are something completely separate from their elemental form. So I've mentioned it. If we don't have pure substances, we also have mixtures. Okay, and mixtures are really probably the things we interact with a whole lot more. Mixtures are where we have two or more pure substances that are combined. It says again there very clearly, physically combined. All right, and each object retains its own properties. Okay, I mean right now I'm looking at a faucet in the room. It technically is a mixture of a metal, a piece of plastic, and probably some others. And there's probably different types of metals on there. Okay? And obviously the plastic is separate. The whole thing we would call a faucet's a mixture of things combined, but each one retains its properties. I can tell very clearly which one's the plastic, which one's the metal, etc. You know, the example that we often give are examples of foods. Okay? When you have a salad, you can taste the tomato, you can taste the lettuce, you can taste the dressing if you're adding the dressing to it. All right, it's not like you add the dressing and all of a sudden everything just kind of merges into one sort of blob. Okay, you still have every unique taste, texture, all of smell of every single thing in that. So it's a multiple types of substances in there. Now mixtures we do separate out into additional types. We have one type which we call a homogeneous mixture. Okay, homo means same. That's the prefix meaning same. It is a mixture with components that it says are evenly distributed throughout. What that basically means is that the whole substance looks like one object. The mixture looks like a pure substance. Okay, if you think of, for example, like salt water, it looks like one substance. All right, you can't see the salt necessarily that is actually dissolved in the water. Yes, you might see salt at the bottom, but that's then not homogeneous. All right, but it is, that salt is spread throughout it. You cannot see, it all just looks like water to you. But when you taste it, obviously you can be like, well, I taste water and I taste salt, therefore salt water. So homogeneous means it all looks the same throughout. All right, it is evenly distributed. Other examples here are solutions that you have. Most drinks are homogeneous solutions. And then you have things like alloys and vinegar, et cetera, et cetera. Heterogeneous mixtures are things where, again, you see actually the different objects that are making up the mixture. So my kind of poor example of the faucet would be a heterogeneous mixture. Again, salads and stuff are heterogeneous mixtures. What we're saying there is the things do not perfectly distribute out evenly, which means you can see certain parts of it at different areas of the mixture. Okay. Now, some are clearly more obvious than the others. All right, when I said something like the salt water with the salt at the bottom of the cup, that would be a heterogeneous mixture then, because it is not evenly distributed out anymore. The salt cannot continue to completely go through the liquid, so you see salt and you see salt water. Okay, so other ones that are examples that are good here, all right, ice cubes in your drink. Soil is a good one because, again, you pick out a thing of soil and it's all sorts of different stuff, even though it might all still be dirt. There's clearly different things in the dirt, like little rocks, different types of dirt or soil are in there. You're talking about clay and everything. One tricky one is blood, okay? And we know that's a heterogeneous mixture as well, because if you do let it settle, you will see different parts of it distribute itself out. You'll see water separate from some of the plasma or other things that are in blood itself, which is very much a mixture. All right, one last one that you probably have not heard about too much is something called a colloid. Okay, it does kind of the name, the sound of it doesn't look like it's like some people are like colloid. It is called colloid. This is a heterogeneous mixture as well, and this one is usually a tricky one because it really does look like an individual substance. Okay, it does look like a homogeneous mixture. All right. But the particles it has these large enough solid particles to remain suspended in solvent without settling out. Over time, if you really let it kind of sit, there will be some settling out of the particles. All right, you might have seen that with milk if you've left milk in your fridge for so long. And I'm not talking about when it curdles or turns gross, it turns yellow and everything. I'm talking about sometimes you can see kind of a little layer of water above the milk itself, okay, in terms of not what's been condensed over it, but the milk, I'm going to just call it lactose, like separating out from the water some. So classic examples here you can see on the right, jellos, creams, milks, blood, okay, things like that, smoke, fog. All right, those are examples of colloids, which again fall under heterogeneous mixtures. Another type of heterogeneous mixture is a suspension. This is the one I was talking about more specifically. So I introduced basically what heterogeneous means, and then there's two types of heterogeneous. There's colloid and suspensions. Suspensions are the ones where you cannot, like the particles are so large they will settle out immediately. Okay, you can go ahead and stir it for a minute, but they will never really dissolve into the liquid, and you will have the two things separate, okay? Obviously, anything you have to shake up would be a suspension because you're trying to distribute that throughout the whole mixture so that, like orange juice with pulp, all that pulp might be settled on the bottom, and you might want to make sure, or you have a lot of it settled on the top that's floating to the top. But you know what I mean with that. For homogeneous, there's only one type of homogeneous mixture, and that's a solution. Now, we do describe solutions with different terms, but a homogeneous mixture is a solution. They are synonymous with each other. They are exactly the same. You can say homogeneous mixture or the word solution, and they both are identical ideas. All right, so a solution obviously is something where it has one or more of what we call solutes dissolved in a solvent. And again, everything looks like a single substance. You have examples down below. The two parts of a solution, you have what's called a solute and a solvent. A solute is what gets dissolved. A solvent is what does the dissolving, okay? The solute is usually present in the smaller amount. It's what you add to the solvent. The solvent, the most likely solvent out there would be water, okay? Water is the most likely solvent. We've talked a little bit about aqueous solutions when we did some chemical reaction things. That's what we're talking about, that they're so common, we call them aqueous solutions, and the solvent is water. But we always say solute in solvent. So if you're trying to identify which one's the solute and solvent, think of the term, think of it as solute is in the solvent. Solute is in the solvent. Solute is added to the solvent. And I already just talked about this. The most common solution is a one that has water as the solvent, and we call that aqueous. All right. Now, this says types of solutions, but again, these are terms that we get when we have a solution. We try to describe it a little bit more, okay? And so there's three adjectives that I can add to the word solution to describe basically how much is in it, all right? And so we have what's called a saturated solution. A saturated solution is one where you have the maximum amount of solute that can dissolve in the solution, in the solvent, and it does depend on temperature. We're going to get to that in a video very soon, another video, okay? So a saturated solution is you cannot fit any more in it at that temperature. You cannot keep on adding it. So we use the trash can as a common example. That trash can, you should fill it up to the brim, and then really technically there should be no more trash that should fit in that, okay? You will see though, just like with a trash can, we can try to overfill it, but we're gonna have to be then very careful with that trash can so it doesn't spill, okay? If you fill it to the brim, none of that trash should fall out. For a saturated solution, none of the solute should settle to the bottom, okay? One way we know we have a saturated solution is if you add any more stuff, any more solute to it, and you keep mixing and mixing and mixing, you will see that extra solute settle to the bottom. Okay, so that's one way we test whether we have it saturated. Unsaturated, exactly as it sounds, means it is not at its maximum amount. Okay, you see an empty trash can right there. You can keep filling that trash can up and it would be unsaturated until you reach the brim, okay? So if you do keep on adding and it does dissolve, that means it is unsaturated. Supersaturated, I like that picture, all right? Obviously means you have overfilled it, you have overflowed it, and now, let's be clear about this, okay? A supersaturated solution means you have overflowed it, but surprisingly, it's still holding more than it should. So I ignore all this other stuff around it for a moment. This is an overflowed trash can. Technically, the trash can is holding all of this extra trash. That's what a supersaturated solution would do. It is overflowed with solute, okay? But it's holding it, all right? It's holding more than should be dissolved at that temperature. It's holding more than it should. A supersaturated solution, just like this trash can though, is not stable. You can come along and try to add a little bit more, but if you hit it the wrong way or add it the wrong way, guess what's going to happen? Boom, some of the trash falls out. That's the same thing that happens with supersaturated. If you try to add a little bit more when it has settled, all of a sudden you might see this overflow amount of stuff try to come out of solution because it's not very stable. One example of supersaturated we always use is basically rock candy. Okay, to make rock candy, lollipops essentially, all right, you actually overflow a solution with sugar, you let it, you saturate it at a higher temperature, you then lower the temperature, But if you keep the solution relaxed, you shouldn't see sugar start coming out. If we usually lower temperature, you should start seeing stuff come out, just like you see with snow and everything. Snow is basically rain is when things become too saturated and then the temperature drops and now the air can't hold it anymore. All right? So that's what we're looking at, and basically with rock candy is it's overflowed, but you lower the temperature, it holds it, and then you try to add, you put a little stick with sugar on it and you dip it in, and all of a sudden you'll get these crystals that form on that because the solution's like, stop it, you've put too much in, have a lot back, and you can create candies with it. Other things we say, these are just other terms related to what we just said. We can say we have a concentrated solution and a diluted solution. A concentrated basically means that you have a lot of stuff dissolved in it. It says in a small amount of solvent. A saturated solution is a concentrated solution. A diluted solution is one that is an unsaturated solution. It means that we have a large amount of solvent and we can technically add more solute. Okay? So that's what we're looking at there. You got a nice little picture of diluted to concentrated. I mean, you know, we do an activity here where obviously we'll have diluted lemonade and concentrated lemonade. Obviously everybody wants to drink the concentrated lemonade because it tastes better. Diluted just tastes like, you know, very lightly flavored lemon water, okay, and so forth. And that's it. Thank you.